How are you guys doing? I have a pretty simple flight planned for us right now. We are currently sitting on the ground at Gitlab, which is a grass field a couple miles south of Tallahassee. We're going to be flying up to Tallahassee International. Should be relatively straightforward. Parking brake disengage, power smooth to full. All right, we're airborne-ish. Come on, getting speed. Flaps up, gear up. All in all, not too bad. I'm gonna sit up in my seat. Nice. We're flying. So let's get up to 1,000 feet. And we need to contact Tallahassee Tower on 1187, I believe is the frequency. Let's get that from here. Tallahassee International, 1187, yeah. I'm gonna do that by hand. I've already got like a yoke and rudder pedals and everything else, so I'm trying to like do this legit. See how we do. Okay, 1187. So we've got 118.7. Just gonna do that. Nope. Okay, we overshot it a good bit, but that's fine. Okay, well we changed the 118, thank you Microsoft. Oh yeah, I forgot, the radios in this game are currently broken, because if you scroll up or down, it still always just goes down. So that's gonna make this really fun. Thank you for that. We're really close. Cool, there's that. So we gotta punch that in. Ooh, actually, yeah, we do need ATIS 119.45. Well, fuck, we passed it. That's fine. Okay, 119.45. Fucking, okay, no, that's it's fine. This is fine. Nope, we overshot it again. This is so much fun. This is what you want to do when you're playing a flight sim, is basically just change radios for 5 minutes. Of course, it doesn't fucking help that this is all set to 8.3 kilohertz spacing by default, even though I'm in the US and we don't use that. Okay, yeah, we're getting way too close to this airport, so we're gonna pull an entire 180 because I can't dial in the frequency that I need and the time it takes me to fly north. We had entire flight plans set up, and I can't dial in this frequency fast enough to even get the weather, much less be actually talking to someone. This is fine. All right, cool. 119.45. Okay, nope, well, we had it. Had it again. God damn it. Okay, well, we have 118.45, so now let's go all the way back around. Yeah, this is getting spicy. Shouldn't be spicy. This should have been flying north and dial a frequency, but this got real fun real quick. Right here is probably a good spot to level, and we'll climb just a little bit. Okay, 119.45. Come on, can we get weather? That is literally the goal right now. I just want weather. I don't even need a landing clearance yet. I just need someone to tell me what the fuck the weather is. Oh, okay, cool. Whew, there we go. There's the weather.
Tallahassee, Airport Information India 17000.
No, fuck this. I don't care anymore. Could you imagine flying an actual, like, flight like this? No, fuck that. Okay, let's go Google, let's see how much a radio panel costs, right? There's so many people playing this game right now. I have a full set of throttles and a full, like, yoke and a full set of rudder pedals and everything. People have to make radio panels for this game. It's gotta be a thing. All right, let's do this. So, flight sim radio controller. What do we get? Okay, that one's $500. That's gonna be a no from me. I don't even see the knobs that you could dial in frequencies with. Maybe they're there? It definitely doesn't do like a full stack. There might be one radio. Okay, 150 bucks for this thing. It's from GameStop. It's Logitech though. 150. Okay, well, I guess Logitech. How much does your thing cost? 150 bucks, okay? What do we get for 150 bucks? Looks like 2 radios. That'll be like a comm and a nav. Usually have 4. Do I have to buy that twice? Like, what? What are those? What the fuck? Those aren't even like real. They don't even look like real flight sim knobs. Like in a radio. Oh, I'm so mad. 150 bucks. 150 bucks. You don't even get knobs that look like the real aircraft, much less feel like them. You get whatever the hell this is. I guess they have buttons that have the little arrows on them. Oh, wow. And you get 2 radios. Again, normally you have a comm 1 and a comm 2 and a nav 1 and a nav 2. So I guess this would be like a comm and a nav, or maybe the 2 comms, but like, what? You don't even get, Christ, 150 bucks. You don't even get real buttons. You only get 2 radios. Like this is literally, I mean, the GNS 450s have 2 radios with 1 knob and 1 button. I guess it's 2 buttons because the little, one of the knobs is actually a button, but like 2 buttons, 2 little knobs. You get 2 radios. It doesn't have to be this complicated. You could have real fucking buttons. We could build this. This would be so easy to build. It's a display, it's 2 knobs, and 2 buttons. Like, you could drive that off of an Arduino. You need like, what is it, 2 knobs, probably gonna be 2 pins each. So we 4 pins for the knobs, 2 pins for the buttons. Like, yeah, you could literally power this off of an Arduino, or even just like the 28 pin pickaxes. And then you just need the display to throw on top of it, which again isn't that complicated. Looks like they use 7 segment. We could throw an LCD display on this. We could have an RGB radio. We could have a gamer quality radio for way less than 150 for just the 2 radios. And then when I need to go build the 4 radio option, instead of $300, it'd be even cheaper than that. Yeah, we could have like full gamer grade radios. Just do the 2 of them for way cheaper than that. Probably half that. Probably less than half that. Fuck this. Let's build a radio controller. It's not gonna look as nice. It's probably literally gonna be a 3D printed shell. So I mean, the fact that you get decals on it is kind of dope, but like, I'm not paying $150 for some stickers. Let's go build a radio controller. Okay, so the first part of any engineering project is to really take inventory and come up with a parts list of things that we need to buy, things that we have, and just overall, what are we gonna use for the project. But before we jump into that, I wanna take a minute and explain the problem for people who aren't terribly familiar with Microsoft Flight Sim. So right now I have the Garmin G1000 booted up in the game, and you have the same issue with pretty much any of the other radios that you'll find. But long story short, we have the comms on the right hand of the screen. These are the frequencies and radios that you use to talk, and we have the nav radios on the left hand side, which you use to navigate. I'm pretty much only focused on nav 1 and com 1. I will be ignoring the standby videos in the first iteration of this, so stay tuned, I guess, for a version 2 that addresses them. Long story short though, if you want to change the whole number of the frequency, you have this big outer knob over here that you can rotate through the whole numbers. It is currently broken, and no matter which direction you turn it, it will only ever decrease that value. The inner knob, weirdly enough, works fine, whereas you turn this guy, the frequencies will go up or down as they're supposed to. Furthermore, you can push this as a button to switch between COM 1 and COM 2, and you can flip the frequencies with this button. So that's pretty much all we need to mimic for our flight controller, right? We need one of these knobs. Pushing the button will switch us between COM and nav, and then pushing this button will change the standby with the active frequency. The active frequency, of course, being the frequency that you're currently navigating or talking on, and the standby one being the one that you're editing, or hopefully the next one that you're gonna need. So when I took inventory and tried to come up with a parts list, basically what I settled on was this. I had a few SparkFun Pro Micro 3.3 volt Arduino boards that I was going to use as the logic controller for everything, and that works great. I already had one on hand, don't need to buy it, sweet. I likewise had a SparkFun serial LCD that I was going to use as the primary display for the radio controller. Again, even better, don't need to buy it, already have it, awesome. So from there, I needed this knob, which I sourced from a company called PropWash Sim. They specialize in making simulation gear, so it's not aviation certified, but it's allegedly built to that same grade, which is really nice because it means that it pretty much has a very, very, very similar feel to the knobs that are actually used in aircraft, and it doesn't cost as much because they get quite expensive. So unlike whatever generic crap that Logitech put on their board, we will actually have a real radio knob, which is pretty cool. And then for the button, I basically just used a generic button that I had laying around. All in all, the only thing that I had to buy was this knob, and even if you were to build this having to buy everything, it would probably only cost you like 45, maybe 50 bucks tops, which again is way better than the $150 that Logitech wants, which again only does COM 1 and nav 1. So yeah, that's pretty cool. Okay, so with all of the parts in hand, it was time to really get started on the meat of the project. And the plan was really simple. I was gonna take an Arduino and reprogram it to show up as a custom game controller. And this custom game controller would have inputs that corresponded to all of the knobs and buttons on a radio panel. From here in Microsoft Flight Sim, I could bind specific buttons on the game controller to actions in the game. And then all I'd have to do is write a mod that scrapes data from the game and sends it to the board so that it can show things on its display. And in this way, I would have physical buttons and knobs that I could interact with, and a display I could look at in real life without having to fiddle around with everything in the game. The two parts of that plan that really worried me were writing a mod for Microsoft Flight Sim because it's a big game, it's inevitably going to be a complicated API surface, and it's also by Microsoft, so you know the documentation's just going to be awful. But even scarier than that was actually getting an Arduino to show up as a custom game controller, because that was going to require me to write an entirely new USB descriptor from scratch and then do a whole bunch of communications with the USB protocol, which is inevitably even bigger and more complicated and worse documented than Microsoft. So I spent an entire night going through open source projects and blog posts and about 400 pages of official technical documentation from the USB organization. And at the end of the night, I got the board to show up as a controller in Microsoft Flight Sim. Microsoft Flight Sim recognized that the board had a button and let me bind that button to one of the knobs in the game. And then when I started the game, I was able to watch the board trigger that event in the game and change the frequency every so often, which was really awesome. And then the next day, while restructuring the project, I accidentally deleted everything. And when I went to my backup, I realized that the folder was empty. So that was really fun, and that leaves us with a very important lesson, and that is, if you're going to make a backup, verify that the backup is actually a backup, and that the files aren't corrupted, and that the files are actually there. So yeah, that was awesome, because that meant that I got to spend another day going through open source projects and blog posts and technical documentation just to get it all hooked up again. And then, because I'm an engineer, and being an engineer means that I enjoy pain, I realized that if I spun the dial really fast like you do in real life, Microsoft Flight Sim only caught 2 or 3 out of the 20 or 30 events that actually got sent because of the way that it pulls the USB device. Basically, whenever you rotate the radio dial a little bit, it sends an event that says, hey, the button was pressed, and then a fixed amount of time later, I have to say that the button was released so that the next time you rotate the knob, I can press it again. And basically the problem was this. If I set that delay short enough so that I could actually send the 20 or 30 events per second required, Microsoft Flight Sim couldn't keep up with them, and it would basically just discard almost all of them. And if I set the delay to be long enough so that it could actually keep up with Microsoft Flight Sim, then the board couldn't actually keep up with the input of the radio knob. So none of that was really ideal, and I ultimately scrapped that approach entirely for a more complicated one. And the more complicated approach was basically that the board would act as a radio, which meant that it had to have all of the logic and settings that a radio has, and then it would respond to the inputs that it has to know what frequencies are currently set, and then I would just send those frequencies to Microsoft Flight Sim. So instead of basically using the board as a game controller and then passively reading the data back from the Flight Sim, the board was actually going to do all of the logic of a radio controller and then just push the frequencies to Microsoft Flight Sims, also that we weren't limited by Microsoft Flight Sim's USB interface. So with that plan in mind, I basically built a test harness at first so that I could start interacting with the knob and figuring out how that works and writing that code. And once that was done, I wrote code for the display, and then I designed 3D printed and wrote code for the frequency change button. And then I really wrote the full package that kind of ties everything together. And throughout that whole process, I kept designing and 3D printing more and more and more of the enclosure so that I didn't have random PCBs just strung all over my desk. Now, throughout this whole process, I did have to implement a settings page, primarily because if you're flying in Europe, you use 8.3 kilohertz channels, and if you're in the US, you use 25. That being said, I am gonna need some names from Microsoft because in the game, it's labeled as 8.3 kilohertz channel spacing, and in the docs, it's labeled as 8.3 kilohertz channel spacing. And nowhere in the technical documentation or in the game or anywhere else do they mention that they don't actually use 8.3 kilohertz channel spacing. They use 6.25. If you go into the game and set 8.3 kilohertz channel spacing and twist the knob once, you will get a channel that is 6.25 kilohertz off of the original, despite being labeled as 8.3 literally everywhere else. Thank you, Microsoft. That was really fun to discover. Anyways, after my frustration at that, I decided that I really had to validate having a settings screen when I only had one setting, and the LCD display that I bought technically is RGB, so I am pleased to announce that I have built the world's first RGB gaming flight controller. Hell yeah, that's a win. And when the whole thing was done, I finally had a standalone radio controller that I could actually tie into a flight sim, but I had not yet tied it into a flight sim. So in order to get the controller talking to the flight sim, I had to write a mod for the flight sim. Now, I thought that this wasn't going to be a very huge deal. I've definitely coded far bigger and more complicated things that live in frameworks that are more complicated than Microsoft Flight Sim. But oh boy, this tells a classic story about the state of Microsoft's documentation. For those of you who have the bliss of not knowing, Microsoft docs are known to be confusing, convoluted, and sometimes just wrong. And this game managed to exceed my already low expectations, all right? So to get us started, Microsoft Flight Sim supports 2 types of mods, one that lives outside of the game and one that lives inside of it. All right, so if you code outside of the game, you have the advantage that if you crash or do anything weird, you probably won't affect the state of the game. So this is the one I went with. It also means that I can use whatever libraries and frameworks and languages that I want. So it was pretty straightforward to write a mod that theoretically could communicate to the controller and push data into the sim. Except that when you code a mod outside of the sim, despite having all of those advantages, Microsoft won't actually let you change variables. You can only get data from the sim, not push to it. So that was wonderful. So I then looked into writing a mod that lives inside of the sim, but you don't just get to use whatever frameworks you want and whatever libraries you want, which meant that I couldn't actually communicate with the flight controller from inside of the sim. So I did what any sane person would do, and I wrote two mods. One that would actually communicate with the flight controller, and then communicate with the second mod, which would actually be able to set the data in the sim. Yeah, you know, super straightforward, real easy. Thank you, Microsoft. After I got that finally set up and basically working in completely different development environments and languages, it did not work. And that's not a big deal. Microsoft outlines a few different ways that you can change data from inside of the sim, and none of those worked either. So after, you know, about a week of self-hatred and just sifting through their code and diving through any forum post I could manage to find, I eventually, in their source code, found a completely undocumented variable that just let me set frequencies from outside of the sim. So I basically am back down to only having one mod once again. Of course, Bill Gates giveth and Bill Gates taketh away. Hold on, who's the CEO of Microsoft? Of course, Satya Nadella giveth and Satya Nadella taketh. That just doesn't have the same rhyme. What I'm trying to say is I immediately broke the USB header off of the logic board, which wouldn't be too much of an issue, but you remember earlier in the video when I said that I didn't have to order one of the logic boards because I had one of them on hand? I had exactly one of them on hand, and I just broke it. So I went to SparkFun to try to order another one, and they didn't have another one. They were completely back ordered. So I had to go to Amazon, who had 3 left in stock, and I ordered 2 of the 3 that were left in stock. So whoever got the third one, you're welcome. And that took basically an entire week to get to my house still. So I just sat there with 99% of a radio controller for an entire week waiting on shipping. And then when it finally got here, I was able to play with it, and there were a couple of kinks, but the biggest one was that if something changed inside of the sim, the radio controller that I built didn't know, and they would like basically get out of sync. And so as a finishing touch, I wrote code that basically completed the loop and made it so that not only could I push data to the sim, but I would receive notifications whenever data in the sim changed and allow me to stay in sync with them. And with that, I finally had a working radio controller. All right. So we're back at Wakula Club Airfield. Emphasis on field, not really much of a runway or an airport, but hopefully this time when we fly into Tallahassee, this should be so much more straightforward, and hopefully the hardest part of the flight is actually the soft field takeoff, which I do not know the procedure for in this aircraft, but we're gonna give it a shot anyway, and hopefully this dude does its job and this whole thing is just a breeze. So with that, please buckle your seatbelts. This will be a quick 10-minute flight. We will be cruising at 2,000 feet. Because this is a short flight, our flight attendants will not have the chance to cater snacks or food or beverages. We apologize. Fasten your seatbelts. Let's do this. Power to full. And the sim thinks the parking brake is on. And power to full. There we go. Let's bring in flaps. Not bad. We are airborne, and then we're gonna climb at 75. I'm gonna sit up in my booster seat, zoom out a little bit. We're gonna climb to 1,000, and while we do that, let's grab the Tallahassee ATIS on 119.45. There's 119. There's 45. Look how easy that was, oh my god. We're gonna level right here. Yeah. All right, cool. And then tower's on 1187. And we can request a full stop. God, it is amazing how easy that was. All right, base runway 27. So we are coming in from the right direction then, because we need to be flying north so that we're entering base for runway 27, which means we're going to be landing to the west. So I'm going to offset us a little bit. We've got the airfield in sight, so I'm going to bring a little bit more power out. We're going to get down to 1,000 feet. Cleared to land runway 27. Bring a little bit more out. Like I said, we need to be about 1,100 feet, I think, is pattern altitude. And we also need to be getting slow so that we can bring flaps in. So I'm going to bring basically power to idle. Normally I wouldn't cut it like this, but again, field of view is so small that it really makes it tricky. We're at a nice 80 though. Okay, we're short, and there we go. Bleed it off, come on. Yep, that's what you want to hear. Ooh, butter. Nice. Dude, we got the first taxiway. That was pretty nice. 121.9er.
Going to 121.9er.
That was convenient. I wonder if they did that on purpose. Anyways, look how easy that was. That comes off, avionics off, electrics off. And that is a wrap. Oh man, that was so nice. Well, thank you guys for joining me on this adventure. I know this has been a bit of an interesting one. Now that I'm recording it, I am fearing editing this down to 15 minutes, hopefully 10, but I'm gonna make it happen. And as an aside too, this entire project is open source. I've got the parts list that I used as well as the source code over on Gitlab. I have all the 3D printed parts over on Thingiverse, and both of those are in the description. So if you want to dive a little bit deeper into what I built and look at how it works, or maybe even build it for yourself, that's all the resources that you guys will need. And if they help you out at all, keep in mind that liking and subscribing help me. Thank you guys so much for watching. As always, I'd love feedback down in the comments, preferably feedback on my engineering and less on my flying. It's getting there, but flying in a sim is really weird. But yeah, as always, I will catch you guys in the next one. Have a good one.